Okay, we're going to go over the Chapter 2 test in 153. Unit 2 test, I should say, not Chapter 2 test. So we have this function, and we want to be able to figure out the zeros. So I've typed it into my calculator, and I'm going to go to Zoom 4 and see if I see it. And I think I got a pretty good view of it. Looks like it crosses someplace not very nice there. It doesn't look like. Let's take a look at see what that is. So I'm looking for the, so you can see what buttons I'm pushing. I'm going to go second, calculate the zero. And I want to look for the zero between -4 and -3. So I'm going to go -4, enter, -3, enter, and it's not in the right place. I'm looking there. No, it's between -5 and -4. So I'm going to start over. Second, calculate the zero between -5 and -4. Now, see it's between there, and I'm going to guess it's -4.5. And it says, no, it's -4.646 if I round off to 3 decimals. That's not a very nice number. I might want to try to find the exact number for that. This is a decimal approximation. Let's look at the one between -2 and -1. Second, calculate the zero between -2 and -1, and I think it might be -1.5, and it says, oh, you are so correct. Oh, I'm so good. -1.5. That's a nice one. I can do stuff with that one. And there's another one between 0 and 1. So second, calculate the zero between 0 and 1, and I'm going to put 0.5, and it says, nope, it's more like 0.646-ish. That's another approximation. Be nice if I knew the exact ones. And then there looks like there's one more. It looks like at 1. So I'm going to check the value at 1, and it says it is 0. So at 1 we get a 0. Now this one looks like it goes straight through. So it looks like it has a multiplicity of 1. This one looks like it goes straight through. So it has a multiplicity of 1. This one looks like it goes straight through. It's kind of hard to see there. I might want to zoom in, but I'm going to leave it. It goes straight through, so a multiplicity of 1. And at 1, it looks like it came down. Let's move this out of the way. Looked like it came down and bounced. So that means it's multiplicity 2. Now with that, I could factor this right now. This is going to be the approximate factors. So f of x would be x plus 4.646, x plus 1.5, and x, this is plus, so it's minus 0.646, and x minus 1 twice. So that makes all 5 degree 5 polynomial. This, though, would only multiply to be an x to the 5th. We need 2x to the 5th, so I need a 2. There's the factored not exact. Now let's get the exact values. So the polynomial, let's get ready to do synthetic division. So we've got 2x to the fifth, 7x to the fourth, minus 14x to the third, minus 10x squareds, plus 24x's, minus 9. And of the nice ones, this one and this one, this is the nicest one, and it happens twice, so I'm going to go 1 into this, add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, and it goes in evenly. And it should go in twice, so I'm going to put it into this. So I'm showing that these are factors. So I'm actually starting with this one. So we're going to have the 2 and then the x minus 1 twice. If this goes in evenly, 2 plus nothing is 2, add, multiply, 2, add, 11, multiply, 11, 6, multiply, negative 6, plus 6, add, I get 9, negative 9, negative 15 plus 6 is negative 9, multiply, and it goes in evenly again. So I've reduced my degree 5 to degree 4 to degree 3, and hopefully I can go a little bit more. I want to find the exact values for those, but I can use this negative 1.5, and I get 2, negative 1.5 times 2 is negative 3, 8. Negative 1.5 times 8 is negative 12. Add, I get negative 6. Negative times negative is positive, and 1.5 of 1/6 and half of 6 is 9. And negative times negative is positive. Add, and goes in evenly. And now I've gotten down to a quadratic. So my other x-intercepts, okay, and this, go back to here first, the factor is x plus 1.5. And we have the opposite of b plus or minus the square root of b squared minus 4 times negative 6 times 2. So that's negative 2 times 6 is negative 12 times 4 is negative 48. All divided by 2a. Okay. And a negative times negative is positive. So that's 64 plus 48, which is 112. And 112 is 16 times 7, I think. Yes. So you don't have to reduce, but I'm going to. I've got negative 8 plus or minus square root of 16 is 4 times square root of 7 over 4. And 4 goes into there, makes negative 2. And 4 goes into this and makes plus or minus the square root of 7. So minus 2 plus the square root of 7 is this answer. And minus 2 minus the square root of 7 is this answer. And so my last two factors are x minus this, so that's plus 2 plus square root of 7, and x minus this, which is plus 2 minus the square root of 7. And that's the function completely factored. Now, some people typed this in on Desmos and tapped to get the y-intercept, and it gave you an approximate answer. The correct answer, if you put 0 in for all the x's, you're going to get -9. If you put in 0 for the x's, you get -9, and the intercept is a point. What are the x-intercepts? They were -2 minus the square root of 7 gave us 0. -1.5 gave us 0. -2 plus the square root of 7 gave us 0. And 1 gave us 0. Those are the x-intercepts. Again, intercepts are points. So you should be giving me coordinates of points. The end behavior. This is a degree 5, which means they have to go in opposite directions. And to get the opposite direction, which way it is, well, this is a positive, so the odds will start from the negative. So this going this way, they'll go down, and they'll go through curves, whatever, and head off to the positive direction on this end. Determine the local maximums, if any. So let's go back and look at our graph. And we know that it's going up, coming down, then going up and down and up. So there's a maximum here, way up there, and there's a maximum here. This maximum is somewhere between -1, 2, 3, -4 and -2. So I'm going to use my calculator's ability here. I'm going to push second, calculate the maximum. That's between -4 and -2. And I'm going to say maybe it's at -3, and it says, no, -3.74. But the maximum is 399.85. Now, for answer questions down below, I'm going to put down here just a note to myself. This happens when x equals -3.74, approximately. And the other maximum, which is right there, somewhere between 0 and 1. So I'm going to go second, calculate the maximum between 0 and 1. I'm going to put a guess of 0.5, and it says it happens at 0.770. That's just a note for further later. But the maximum, the correct way to write the maximum is just how big is it? And it was 0.161, 162, 0.162 rounded. So this and this are the correct local maximum. Local minimums. Well, if it goes up, then it must go down and up. So there's a minimum somewhere between -1 and 0. So we're going to try to find that. Second, calculate the minimum between -1 and 0. And I'm going to guess -0.5, and it says the minimum is -25.27. And a note for further use, it happens that x is approximately -0.835. And there's another minimum. It went down, it came up, and it dipped a little bit here at 1. It dipped down to 0 at x equal 1. Now, I don't need this in this part, but I can use it down here. This is the local minimum, and that's the local minimum. This is where it happened at. Now, this says determine the intervals where the y values, determine the x's where the y's are less than 0 or equal to 0. Well, if this goes up and down, all of this, the y values are less than 0. And they happen for all the x values going from negative infinity up to that root. So from negative infinity up to that first one, which was negative 2 minus the square root of 7. Which you could also just use the negative 4.646. Could use that in there. Union. So this part was negative. This part was above the x-axis, it's positive, and then it goes negative from there, negative 1.5, to 0.646. Now, I'm not looking at the y values other than seeing whether they're positive or negative. I'm answering this in terms of the x values. And the x values where this started being negative is at negative 1.5, and the graph was negative clear up to the minus 2 plus the square root of 7. That 0.646. Then it went positive for a little bit, then it went back to 0, and we can be equal to 0, so we have to union. Where was it 0 at? And it was 0 at 1. So from 1 to 1, it was greater than 0. Oh, and these are equal, so I can do a solid bracket there. Solid bracket and solid bracket. These should all have been solid brackets because that's where the numbers that are approximately the ones that make it equal. Now, when is it decreasing? Well, again, this function is going up all the way to this maximum. Then it comes down, so it's decreasing from there to the bottom, and so we don't want to put the y values. We want to answer in terms of the x's. Where is it decreasing? So it starts decreasing just after the maximum, which I put here. So this is where we're using these. So it started decreasing when x was negative 3.74. Just after that, it's going down. And it goes down to the minimum, which was way down here. So it's at this place. So the x value is the negative 0.3835 rounded. So between this x value and this x value, between this x value and this x value, from where the max is to where the min, it decreases. Then it increases all the way to where that max is, and that max happened at 0.7770, and it got up to that height, and then it dropped down to 0 at 1. So from 0.777 up to 1, it was decreasing. At 1, it changes to increasing. So there's the answer for where it was decreasing. It was decreasing on this piece, and it was decreasing on that little piece there. Okay, that was the longest and hardest problem. The rest of these, I think, are much easier. So if you're going to have a hang time and you're doing it in feet, you have to use the acceleration, which is in feet. And the gravity acceleration is negative 32, but it's half of the acceleration that goes in the equation. So the height after some times t is going to be the negative 16 in feet per second times, to make it be at ground zero when the punter kicks it, you're going to have to put in a t, and it comes back down at 4.2 seconds. It's going to have a t minus 4.2. That's it. Now determine how high it is, the height in feet of the football when it's kicked, what it's kicked to. So I'm going to go and type this equation in. Negative 16x parentheses x minus 4.2. And if I go and graph it, it'll probably go off my graph and come back down. And so it's going to have a maximum somewhere around 2. So I'm going to go second, calculate the maximum. That's between 0 and 4.2. And I'm going to guess about 2. And it says, nope, 2.09. 2.1 roughly. It's going to happen at t equal 2.1 seconds, but they didn't ask me for this. It wanted the height, and this calculator is saying it's 70.56. It's going to be 70.56 feet in the air at 2.1 seconds. Now, I could have gotten that also by just typing this equation in like I did and going second table set, make sure the independent variable is on ask for table set. Go to second table and type in 2.1 half of the time. And it tells me 70.56 is how high it would get. Now it says determine the average velocity between 1.2 and 1.3. Well, if you got this table set like this, we can type in 1.2 and 1.3. At 1, and we do at 1.2, it was at 57.6, and at 1.3, it was at 60.32. And we find the slope between them to find the average. So we do 60.32 minus 57.60 over 1.3 minus 1.2. And that turns out to be, just doing the math on that. Just going to look what my key said. 27.2. This is the height. That was in feet. Over, this was the change in time, which was seconds. So its average speed was 27.2 feet per second at some, on average, between 1.2 and 1.3 seconds. It slows down, and by 2.1 it goes to 0, then it picks up going down. How fast does it get going just before it hits the ground? Well, we can do several things here. The easiest might be to say, let's ask what it's doing at 4.1, enter, and 4.2. 4.2, it's on the ground. At 4.1, it's 6.56. So we have 6.56 minus 0 over 4.2 minus 4. Oop, got it backwards. 4.2, it was on the ground. So 0 minus 6.56 over 4.2 minus 4.1. So this is 0.1 into negative 6.56, which is negative 65.6 feet per second. Now, we could have even done it closer. We could have done 4.199 and 2, And then we would have gotten the difference here is 0.001, and we would have gotten 0.0672 divided by 0.001 and gotten 67.2 feet per second, and this would have been negative. And it means that it's falling at 67.2 feet per second. So those are average velocities near the end. Either one of those works. Okay, number 3. I want you to show me you know how to complete the square, and then use that to find the vertexes and access the symmetry. So to complete the square, you factor out the constant that's the leading coefficient out of the first two terms. And so you get 4 times x squared. 4 times x squared is 4x squared. And 4 times what is 16x? 4x. Then you go plus something minus something. And then leave the minus 2 hanging on the end. Now we got 4. I'm going to use brackets for these two parentheses. And we're going to have x squared plus 4x, which is what we get if we do the square of x plus half of that. That squared is x squared plus 4x plus 4. If you multiply this out, you get x squared plus 2x plus 4. So we only had the x squared plus 4x. This has a plus 4, so we need a plus 4. All of this is part of this, but we can't just add 4, so we have to subtract 4. So we got minus 4 still in this bracket, minus 2. So the 4 is times this, and the 4 is times the minus 4, which is negative 16 minus 2, negative 18. So this says we have a parabola that's moved minus 2 and down 18. So that's where the vertex must be. If it's moved minus 2 and down 18, this is where the vertex is located. And the center line, since it's moved minus 2, is at x equal minus 2. It's a line. You have to write the equation of a line. Center line, or axis of symmetry. That's that one. Now we're going to do the rancher that's making 5 adjacent lots using 500 feet of fencing. So it's got to fence this side and this one, which is the same length, and that one, and that one, and that one, and that one. And it has to fence this side, and 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 this side. So that 500 feet of fencing has to cover 1, 2, 3, 4, 5, 6 X lengths, and 1, 2, 3, 4, 5, and 5 is 10 Y lengths. And we're supposed to maximize the area. Well, the area is going to be X times 6Y, or times 5Y. 1, 2, 3, 4, 5, times 5Y. We have a function that has 2 variables. We want to maximize. We want it to have 1 variable. So we're going to solve for y in this by subtracting 6x from both sides. Is 10y. And I can divide both sides by 10 and get 500 minus 6x divided by 10 is y, and I can use this for y. So my area is x times 5 times 500 minus 6x over 10. And I can reduce the 5 with this and put a 2, or I can just type it in like this. Or I could multiply this out. I will do the reduction here just so you can see this. 5 goes in there 2 times. 2 goes into that, would be 250. 2 into that is minus 3x times x. And so this is 250x minus 3x squared. And if I want to find the vertex of this, I can go minus b over 2a and plug it in here and find the area, but that would be the x that does this. So minus 25 over 2 times this, which is negative 6, which is 25 divided by 250. Listen to my phone ring in there and got me confused. So 250 divided by 6, I think, is 41 2/3. And that's the feet. These are, we're doing fencing, so this is feet. That's the x. That's using this method. You could also type it into your calculator and do, if I could even type this one back here, x times 5 times parenthesis a fraction, parenthesis 500 minus 6x, close the numerator, divided by 10. And if I graph that, it went up and it goes off my screen. So I'm going to go, the x has to be something between 0 and maybe 100. The x value, we know it's 41.3423, but I'm going to go 0 and 100. And my y is going to be something between 0 and, I don't know, maybe 2,000 square feet. Let's graph. It's more than 2,000, but you can see it going up and coming down. Let's go higher. Let's go to 5,000. Still goes off the graph, but you can see it, and it happens, a height somewhere in here gives the maximum area. Second, calculate the maximum. That's somewhere between 20 and 70, and my guess will be 50, and it says nope, 41 2/3. So that's getting it from just graphing it. So how do I get the y? Well, the y is 6 times this answer subtracted from 500 divided by 10. Well, 6 times this, I've done it a few times, is 250. Some of you may not know how to do that on a calculator. You can use this x, 61.66666 times 6, but I can also type in 41 plus 2 divided by 3. That's how you type in 41 2/3 times 6 is 250. 500 minus 250 divided by 10. 250 divided by 10 is 25 feet. Is how wide the pen is, 41 2/3 by 25. And that's the dimensions of each of the little pens. The dimension of the big pen is 41 2/3 by 5 of these. 5 times 125 feet. Okay. This one. So we got to take, using long division, 6x to the third minus 21x minus 6 divided by 2x squared plus 7x. So what do I multiply this by to get this? I think 3x times 2x squared makes 6x to the third. So I multiply those and I get 6x to the third. Multiply these, I get 21x squared. X times x is x squared. And then I draw the line and change these signs so I can add like terms. These add up to be 0. These are not like terms, so I get negative 21x squared minus 21x minus 6. 2x squared times what makes negative 21? Well, it'd have to be negative 10.5. So 10.5 times this is negative 10.5 times this is negative 21x squared. Negative 10.5 times 7 is 73.5. Negative 73.5x. Got to subtract, so we change the sign so we can add like terms. These add up to 0. These are like terms, and so negative 21 plus 73 is 52.5x minus 6. X squared, we're not going to be able to multiply by anything to get x, so we're going to get plus 52.5 minus 6. My remainder divided by the divisor, 2x squared plus 7x. I could do this one by long division, but I want to see that you can do synthetic division. And so on this, the coefficients are 2x to the fourth. So then I have to ask myself all the way down, how many x to the fourth? 2. How many x to the thirds? 2. How many x to the seconds? Oh, none. How many x to the first? Negative 3. And the constant? Negative 5. So you got to have a placeholder in there. And we're dividing it by, let's see, what makes this be 0? I think that's a negative 2. Use what makes this be 0, a negative 2, not plus 2. So 2 plus nothing is 2, times a negative 2 is negative 4. Add, we get negative 2. Negative times negative is positive 4. Add, we get 4. Multiply, we get negative 8. Add, we get negative 11. We get positive 22. We add, we get 17. So that's the remainder. We went from an x to the fourth down 1 degree, x to the third. So our answer is 2x to the thirds minus 2x squareds plus 4x minus 11 plus the remainder over the divisor. This divisor was x plus 2. All right, 3 more. 5-degree polynomial. Negative 3 is a 0. That means the factor is x plus 3. X minus the 0. X minus a minus 3 is x plus 3. Multiplicity 2, so I square it. So far I have a degree 2. 1's a 0, so I have x minus 1 as a factor. Now I'm up to degree 3. 1 plus 3i is a 0, so x minus that is a factor. So minus that would be minus 1 minus 3i. So that's degree 4, but we got to get to degree 5. But when there's a complex answer like this, or one with a square root, they come in conjugates. Its conjugate is 1 minus 3i. Because a quadratic formula, this comes from the square root, and the quadratic formula is something plus or minus the square root. And we're getting the plus one, so we have to do the minus one. So if that's the other zero, the other root, the other factor is x minus this, so that's minus 1 plus 3i. And all of this could be times any number out here. I'll just leave it 1, and that would be a polynomial that has those roots. Now reverse that. If we have a polynomial that has a double root at minus 2, means at minus 2, at x minus 2 means at plus 2 it bounces. If it has x plus 5 at minus 5, single root, it goes straight through somehow, either coming down or going up. And if x plus 1 is a factor, at minus 1 it goes straight through. So it bounces here, goes straight through, goes straight through. This is a x times x, because it's squared, times x times x. There's no negative x's, nothing to make it negative. So a fourth degree, 1, 2, 3, 4, it's got to come from above, go up, and if it bounces, it's got to go something. So it's got to look something like this. Now you could just type it in the calculator and see it, but you should be able to read just straight from it. It looks like this. And we want to know when this, the y values for these x's, are greater than 0. What x's make the y values greater than 0? Well, this part's greater than 0. This is less than 0. This is greater than 0. And this is greater than 0. And this is equal to 0, equal to 0, and equal to 0. We don't want equal. We don't want less. So we want for the x's negative infinity up to negative 5. It's greater than 0. Then it goes 0, negative, 0. Then it's greater than 0. So from negative 1 to 1, it's greater than 0. Then it's 0. We don't want 0. If I had equal, we wouldn't have to split this up, but we don't want it. Union, and then after that, it's greater than 0. So from 1 to infinity. And finally, write an equation for this. Both are down, so it has to be even degree. Looks like minus 1 is a triple. Multiplicity of 3. And at 2, it's a double. And a single at 3. So it must be x plus 1 to the third, x minus 2 to the second, and x minus 3 once, and times some number is the function. And at 0, it's supposed to be 1. So if I put in zeros here, I'm supposed to get 1. So we can figure out a by doing that. 0 plus 1 is 1, cubed is 1. 0 minus 2 is minus 2, squared is plus 4. And 0 minus 3 is negative 3. So this is negative 12 times a is 1, so I divide by negative 12, and a has to be 1 divided by negative 12, and so my function should be negative 1/12 x plus 1, x minus 2, x minus 3.